Hello everyone, and welcome to this lecture on bridge maintenance. This is part of the Indian Railway Bridge Manual, Chapter 2. Whether you are preparing for a railway engineering exam or simply want to understand the structured maintenance of bridges, you are in the right place. Let's get started. Part A, General. We'll start with the basic roles and responsibilities in bridge maintenance. 1. Responsibilities of engineering officials. There are three main types of officials involved in bridge maintenance. Let's break them down. Works inspector or permanent way inspector, they maintain the foundation, flooring, substructure, bed blocks, and protection works of bridges. They also maintain superstructures of arch, pipe, box, PSC and RCC slab bridges, and the steel work of girder spans under 12.2 meters. Permanent way inspector. This person maintains the railway track on the bridge and on its approaches. They also look after appurtenances like guardrails, name boards, footpaths, trolley refuges, and sand bins. Clearing the waterway of any blockages is also their duty. Bridge inspector. Now, this person handles the bigger, more complex structures. They are responsible for steelwork of all girder bridges with a span of 12.2 meters and above. They also look after superstructures of RCC and pre-stressed concrete bridges, and all bearings used in those bridges. 2. Action to be taken after inspection of bridges. After a bridge is inspected, what comes next? Let's understand the follow-up actions that engineers must take. First, any necessary repair work should be executed as quickly as possible. Time is critical to avoid further deterioration. Maintenance teams under the divisional or senior divisional engineer, including assistant engineers, are expected to manage repairs and maintenance of foundations, protection works, track over bridges, approaches, guardrails, and all the superstructures, whether it's arch, pipe, RCC box, slab, or steel spans under 12.2 meters. Additionally, it's important to clearly mark key indicators like highest flood level, HFL, danger level, foundation details, and remove encroachments or debris blocking waterway. For larger structures, like steel girder spans 12.2 meters and above, the bridge engineer takes charge. They are responsible for repairs such as painting, riveting, welding, and maintaining bearings and holding down bolts. Part B, Painting of bridges. 3. Painting guidelines. Painting might sound like a minor job, but for bridges, it's a major part of preserving the steel and markings. The date of the last painting must be written in white paint on the left girder of the first span. For major bridges, paint the date at both ends. Highest flood level, HFL, is marked using a 25 mm broad white line with the year noted in 100 mm figures. The placement depends on bridge length, one abutment for short bridges, both ends or piers for longer ones. Direction of flow should be clearly marked in white on an abutment or pier. Important bridges should display name boards showing the river name, number and length of spans. These are fixed 15 meters before the bridge. Danger levels are marked in red, and at canal crossings, the full supply level is marked similar to HFL. Part C, Foundations, protection works and waterways. 4. Maintenance of foundations. Let's now talk about the very base of any bridge, its foundation. This is where it all begins. Shallow foundation. If the depth below bed level is less than 2 meters for arch bridges, or 1.2 meters for other bridges, it is termed a shallow foundation. These are vulnerable to scarring, especially in sandy soils. To protect these, engineers use cement concrete flooring, drop walls, or curtain walls. These should be at normal or slightly lower than the bed level to account for retrogression of the stream bed. If a scour hole develops downstream of drop walls, fill it with boulders or wire crates filled with boulders. Deep foundation. This is where the foundation extends well below the maximum scour level. Generally, no protection is required unless unusual conditions exist. In severe scour zones, engineers may drive piles around the foundation and fill the space with boulders or sausage crates. 5. Maintenance of protective works. During floods, rivers change course or flow with immense force, threatening the bridge. That's where protective works come in. Types of protection include guide bunds, marginal bunds, spurs or groins, aprons, closure bunds, assisted cutoffs, and approach banks. Stone pitching is used on slopes and bunds to prevent erosion. Damage to walls must be rebuilt properly to prevent pitching from sliding. 6. Maintenance of waterways. A bridge is only as strong as the flow it allows. Waterway maintenance ensures there is no blockage or flooding risk. Remove all obstructions from the waterway, both upstream and downstream, within railway limits. Boundary pillars must be installed on both banks of rivers to prevent encroachments and illegal construction. Part D. Maintenance of substructure. 7. Abutments, piers, wing walls, and return walls. Now let's explore the maintenance of the substructure, which includes abutments, piers, wing walls, and return walls. These components support the bridge superstructure. Weathering happens due to constant exposure to changing weather. Remove the damaged layer, clean the surface, and repair using plaster, uniting, or grouting as required. Leaching of mortar indicates loss of strength. Check joints for powdery material. Use cement or epoxy grouting followed by repointing. Leaning or bulging walls. This may be due to back pressure from water or improper foundation. Ensure drainage using weep holes and replace poor backfill materials with granular soil. Use buttresses if required. Cracks in masonry. Vertical cracks are from uneven settlement. Horizontal cracks can be more serious, possibly due to design issues. Mark and monitor cracks using telltales, and repair using grouting or jacketing based on severity. Part E. Maintenance of arch bridges. 8 common defects and remedies in arch bridges. Arch bridges have been around for centuries. But they too need modern care. Let's look at common issues in arch barrels and spandrel walls. Cracks extending from the substructure to the arch barrel must be grouted and monitored. These often result from unequal settlement. Transverse or diagonal cracks in the intradoors of the arch barrel are serious. They indicate tensile stresses. Strengthening or rebuilding may be required. Crushing of masonry could be due to leaching, weathering, overloading, or lack of cushion. Each cause requires a specific remedy such as grouting or reducing load. Keystone or Wusoyer loosening, strengthen the foundation, increase cushion, or use deep pointing as needed. Longitudinal cracks away from the spandrel wall can occur due to differential deflection or settlement. Investigate and fix accordingly. 9 defects in spandrel walls. Spandrel walls sit above the arch barrel. Cracks here often signal poor drainage or overloading. Clear weep holes, reduce surcharge, or use epoxy grouting as necessary. If spandrel walls bulge or tilt, tie rods may be used. In severe cases, partial rebuilding may be needed. 10 other instructions for arch bridges. Avoid joints over the arch, place them over the haunches instead. Use clean ballast and flat bottom sleepers. Keep track properly aligned on curved arch bridges. Do not disturb compacted fill unnecessarily, use porous material and ensure proper waterproofing if repair is done. Part F. Common repair techniques. 11. Cement pressure grouting. Now let's talk about how we repair cracks and damaged masonry. The first technique is cement pressure grouting. Used for dormant cracks, hollow masonry, deep leached mortar joints, or honeycombed concrete. Grout mix, cement, sand, and water. Water-cement ratio between 0.4 and 0.5. Equipment includes compressor, grouting pump, pressure mixer, GI pipes, and drills. Holes are drilled near cracks, GI pipes inserted, and cement grout is injected under pressure. 12. Epoxy grouting. Epoxy is a high-performance chemical used for narrow and active cracks. It's quick setting and has excellent adhesion. Composition, resin and hardener, sometimes mixed with filler like silicone flour. Requires injection equipment, compressor, and safety gear. Grooves are prepared along cracks, injection pipes inserted, and epoxy pumped until it appears at adjacent holes. 13. Shotcreting uniting. Guniting is a dry mix technique where mortar or concrete is sprayed at high speed to repair spoiled surfaces or weak masonry. Requires guniting machine, air compressor, nozzle, and reinforcement mesh if needed. The surface must be clean, damp, and free from loose material before application. Curing should be done for at least 7 days. Part G RCC and PSC superstructure maintenance. 14 Periodical maintenance. Superstructure of RCC and PSC bridges also require regular attention. Keep bearings clean and free of debris. Drainage systems must be cleaned, especially before monsoons. Maintain protective coatings. Avoid water stagnation on deck slabs. 15 Common defects and repairs. Look out for signs like honeycombing, spalling, and cracks. Dormant cracks can be repaired by cement or epoxy grouting. Strengthening techniques include external pre-stressing, vertical for slab joints, longitudinal for girders, and bonding with steel plates. Part H Maintenance of steel girders. 16 Loss of camber. Camber is the upward curve in girders to account for loads. Loss of camber could indicate overstressing or corrosion. Solutions include strengthening, replacing weak rivets, or replacing members if needed. 17 Residual fatigue life. Old steel girders must be monitored based on traffic load, GMT, and age. If fatigue life is low, impose speed or load restrictions. Part 1 Crack repairs and rivet maintenance. 18 Crack arresting and strengthening. Let's now talk about visible cracks in steel girders. These must be taken seriously to prevent structural failure. First, drill a small hole at the tip of the crack to stop its propagation. This is called crack arresting. Next, provide strengthening by adding a cover plate or angle section using rivets, HSFG bolts, or welding. 19 Loose and missing rivets. Rivets are like the fasteners of the bridge. If they're loose or missing, they must be fixed immediately. Inspect for loose rivets using a hammer. If sound is dull, the rivet is loose. Replace using pneumatic tools, and if multiple are missing, strengthening must be planned. 20 High-strength friction grip, HSFG, bolts. These bolts are used in modern bridges. To prevent theft, apply locking agents or tack welding. Part J Maintenance of bearings. 21 Types and upkeep. Bearings are components that allow the bridge to move slightly due to thermal expansion or loads. They come in many types. Common types: sliding, rocker, roller, elastomeric, and PTFE bearings. Bearings should be inspected every 3 to 5 years and cleaned and greased if required. Look for signs like excessive vibration, cracks in elastomer, or off-centering. Replace bearings if needed, preferably with modern types. Part K Painting and protection against corrosion. 22 Painting steel structures. Painting is essential to prevent rusting of steel bridges. Surface must be cleaned before applying primer and paint. Common primers: zinc chromate or red oxide. Final coat: aluminum paint or grey paint conforming to standards. Paint in dry weather, using brushes or spray, and always note the date of painting on the girder. 23 Metallizing and epoxy coating. For enhanced protection, metallizing, spraying zinc aluminum, or multi-layer epoxy coatings are used. Ensure proper bonding of layers and confirm dry film thickness using ADFT gauge. Part 50 General precautions during maintenance. 24 Safety measures. When working on bridges, safety is non-negotiable. Always deploy lookout men during work on through bridges. Use caution orders and necessary protective equipment. Ensure that no staging, scaffold, or tool interferes with moving dimensions. On electrified sections, take proper power and traffic blocks. Do not contact OHE lines or earthing structures. Conclusion. So that brings us to the end of our lecture on bridge maintenance. We've covered everything from foundation care to bearings, painting, and safety. This knowledge is vital for engineers working in Indian Railways or preparing for technical exams. Thank you for watching, and stay tuned for more.